Hi everyone, I'm Levin, the product owner of Settler AI. Today our team is excited to present the final demo of our project. Buying a home in Australia can be overwhelming, especially for first home buyers and new migrants. Information about property loans and superannuation is scattered and full of complex terms. Settler AI solves this by bringing everything together in one platform, intelligent, trustworthy, and easy to understand. It guides users through the entire journey from exploring suburbs to simulating loans and understanding policies, all powered by AI explanations and clear data insights. We are a full-stack team who built Settler AI completely from scratch in 12 weeks, designing, coding, and deploying every layer from front-end to back-end and AI. Our front-end is built with React and TypeScript, use MUI for a smooth user experience. The back-end runs on .NET 8 with PostgreSQL and our CI/CD pipelines on GitHub Actions deployed seamlessly to AWS. We also use Python and LangChain to power AI-driven explanations and data visualizations. Now let's move on to our first core features of our project, login and registrations.
Hello everyone, I'm Barry. Now let me introduce our first section, login and registration modules. Joe and I are the co-developers for this section. Login and registration can protect data and features, enable personalization and save progress. And also it can improve the analytics, building, and the support. First, I will introduce the login process and the authentication part. User input their email and the password at the front end. Our server will check if the email and the password is correct. When it is correct, server can send back access token and the refresh token. Here, the access token is for the short-term login within 2 hours, and the refresh token is for long-term login within 7 days. And we store the access token and the refresh token in HTTP-only cookies for security. Each service request will take the access token in their headers, and our server will check the validation of the access token. And if the access token is expired, a refresh API will be called to renew the access token by using the refresh token. We also implement the brute force attempt protection, and in this case, if the same API address attempt more than 5 times in 15 minutes, this API address will be temporarily blocked. Now let's move to the registration part. At the front end, we first check the input format and the password strength, and then our backend will check if the email has been used and if the account has been activated. If not being used or also if not being activated, our server will generate a 6-digit code. This code will be sent to user's email, and the user can use this code to activate their account. So for the last part is about the third-party login. So in this part, we support 3 different providers, including the Google, the Facebook, and the LinkedIn. And our third-party login can support these 4 login scenarios, especially when users have used their Google email to registration and log in our website. For the next time, if they want to use the same Google account but using the third-party login method, our backend will merge these 2 different login methods into one account, which is more convenient for our user. Okay, now let's show a demo for this section. So here is our homepage for the Settler AI, and now first I will use my Google email to register a account. So I just type in my name and my email address, and also I will type in my password, and you can see here it can provide a password strength, and also click the create account. Okay, so now the server have sent a verification code to my Gmail, and you can see here we got the verification code, and just copy this code here to click continue again, and now I just that means the registration progress has been successfully, and now I will use the email and my password to log in our website. So we also can click here to check if our password is correct, and also we will check this button. That means we will use a long-term login, and we will get the access token and the refresh token. And now we log into our homepage, and you can see here I get our user information. And now if I log out and I use the third-party login method, so if I click the sign, use a Google account, and also we use the same account, and click continue. Okay, and now we can also log in this page. So this for the login registration and the third-party login method. Now let's move to the next part.
Okay, hi, I'm Melly. I'm going to present the search and suggestion service and the suburb report page. For the search service, firstly, the function passes the query into keywords, identifying suburbs, states, postcodes, or property types. Next, it decides the search direction, whether to query properties or suburbs. Then it builds the database query dynamically and fetches matching record. Finally, it formats the result into a standard output, which is a suggestion list ready for display on the front end. And then the user can choose one from the suggestion list to generate the suburb report. And this report including the income, employment, property market insights, demand and development, lifestyle and accessibility, and safety
and Sheldon, responsible for the development.
And then I'm going to show the demo. So this is our home page, and then if we search, and then we can see a page like that. So it's a lot of information fit. And also you can export the PDF. So that will generate a PDF file for you. Yeah, that's it. Thank you. Let's move to 11.
Thanks, Melly. Now I will introduce our loan calculator. Our loan calculator repayment is designed like a real bank engine, precise, transparent, and built for scalability. It allows users to calculate repayments and run stress tests directly on the platform, or even use it independently, driving the traffic and engagement. At the same time, it serves as the foundation for AI consultation, enabling our assistant to explain repayment structures and support future financial calculators with the same engine. Technically, the calculator follows a clean, layered architecture. We introduced a facade pattern that separates the app's workflow from the financial core, making the system highly textable and easy to maintain. The facade acts as a single gateway, connecting the service layer with the computation engine while keeping the business logic independent. Inside the core, a piecewise amortizer orchestrates the process and delegates complex math to two specialized engines, P&I and interest only. This module design allows us to handle multi-phase loan structures just like a real bank while keeping the logic simple and extensible. To optimize performance, our engine factory uses lazy initialization, creating only the engine needed for each request. All calculations are handled in cents for bank-level precision, and our strict detailed contracts ensure reliable communication between front-end and back-end. Beyond accuracy, this design sets the foundation for AI explanation, allowing our AI assistant to narrate repayment changes and financial scenarios in simple language. In short, this isn't just a calculator, it's the engine that powers financial precision and user trust across the satellite AI platform. Now let me quickly show you how our loan repayment calculator works. Suppose I'm buying a property for $600,000. I will enter that here. I'll set the interest rate here and enter loan term with monthly repayment. When I click calculate, the system instantly generates a real bank rate repayment schedule using our finance core engine. Here you can see the monthly repayment, total interest, and income ratio. Now let's test a different scenario. If the interest rate raises, I can simply adjust this slider and the calculator immediately updates the repayment result. This makes it easier for users to understand how interest changes will impact their budget, while also powering our AI assistant to explain repayment structures in plain language. Next, we will introduce our superannuation projection planner.
Thanks, Devon. Hi, everyone. I'm Jasper. Now, let's look at the super estimation tool. These features co-developer include me and Devon. Many first-home buyers don't realize they can withdraw money from their super to boost their house deposit. And even they know, most don't understand how this choice will affect their future super balance and retirement. So, our goal is to make this effect clear and visual. To achieve this, we built a feature that estimates a user's super balance and retirement considering their income, age, and withdrawal amount. Here is the simplified end-to-end architecture. It starts with the user input. Then the front end immediately performs the client-side validation. This not only improves the accuracy, also enhances the user experience by preventing frustration and unnecessary errors. On the back end, we recheck the input for safety and consistency. Then two services will handle the logic. The first one validates eligibility and ensure withdrawal amount stay within the official limit. Another one simulates annual super growth to estimate final balances. Finally, the backend will send the result back to the front end and display a visual comparison chart showing balances with and without withdrawal. This workflow ensures a consistent and user-friendly experience from the input to insight. And now let's see how the front-end experience supports user interaction. On the front end, we built a responsive interface with tool tips. When users hover over this icon, the short explanation appears to help them understand each input field. This improves usability and reduces confusion for the first-time user. If the user enters an invalid value like negative income, or when this checkbox is selected but the withdrawal amount is missing, the system will show the inline error message and start processing. When all valid data is submitted, the backend performs the necessary calculation and return the result, which will be shown as a comparison chart and a summary card here, helping users visualize the difference between two scenarios. We also add a link to Australia government website so the user can get the latest policy information. This helps first home buyer make better financial decisions. Next, let Carlos tell you more about exploring suburb.
Great, thank you, Jasper. My name is Carlos, and I work on the front end and back end of the suburb map and summary section. Right now, the suburb info is so fragmented. For example, like potential buyers, they want to know the suburb security and the suburb affordability info. They do not know where to look for, and our features fills that gap. So this is the architecture diagram. First of all, when the user clicks the map in the front end, that will send the suburb name, postcode, and state code. to our backend. And then in the backend, it will further break down into 4 different steps. And each step will generate a data in a single detailed data structure. In step 1, we try to match the suburb info from the front end with our database to see whether we do have that suburb info. We will first try to match our suburb postcode with our database. If nothing found, we will use the suburb name. If nothing found again, we will use the save code. Having 3 parameters increase the chance that we can find the matching suburb in our database. If the matching suburb is found, the info will be stored as the overall DTO. We will also get the unique suburb ID for this particular suburb in our database. This ID is very important because we depend solely on it to perform data search. We will then pass this suburb ID as parameter for step 2. Next, in step 2, we use this suburb ID to fetch the median property price, the crime rate, and the affordability from our database. The found data will also be stored as a matrix section DTO. For crime rate and the affordability info, we will pass them as parameter to step 3. In step 3, we will decide whether that suburb is safe based on the crime data. First, we will compare the suburb crime rate with the median crime rate among all suburbs in Melbourne. If the value is below the median crime rate, then we will mark that suburb to be safe in the highlight section. If not, we will skip it. We will then put these labels in the highlight section DTO. In step 4, we will generate a summary table based on the metrics and info we gather from a database. The data will then be stored as a summary section DTO. Finally, we combine all 4 DTOs together into a single top-level DTO and return it to the front-end summary calc section. Now, let's move to the demo. So this is the map on our platform. User can simply zoom in and zoom out. They can also reset to the default zoom level and position. For the summary tab, we can see the suburb section, the matrix section, the summary section, and finally the highlight section. So let's say I'm a potential buyer and I want to know which suburb is safe to look for. And when I click this map, this suburb called West Melbourne, we can see that the highlight section is strong growth, but it isn't safe. I want to find something safe to stay in. When I click another suburb, Southwest, we see that the safety rating here is high. And in the highlight section, it says that the crime is low. That's why I may be interested in this suburb. So when the user navigates different suburbs on our map, they can narrow down the list of suburbs that they're interested in. And later when they reach out to the agents, they can simply ask the property in these suburbs and then speed up the whole conversation and help the agents to close the deal quickly. So that's all for me. I'll now pass it to Neil for the feature of the property page.
Thank you, Carlos. Hi, everyone. I'm Neil, and I built the property page. So because nowadays we often see users jump across the multiple platforms just to piece together the whole picture of the property, right? So we want to fix that. So the property page brings every details, every insight and recommendation together, help the user making smart decision faster. So the backend flow is quite straightforward. You just start with the receiving a property ID and then find a similar listing in the same suburb. If there's not enough matches, it widens the search to the nearby suburbs. And so everything's mapped through the auto mappers and into clean details before sending the final list to the front end for the rendering. So the front end uses
sorry for interrupting.
You didn't share
we
the
can
full
only
screen.
see partial of the screen, yeah.
Oh, I'm sorry, this. So now it should be the full screen, right? Can you guys see the full screen?
Yeah, that's good.
Okay, great. Yeah, so I'll go back to this is the backend. You just find this nearby sub-brands and properties. But there's not enough, just find more and then just And for the front end, you use reg query to fetch and catch similar properties when user click a button, view more like this. And so it will load more results from the backend and remove duplicates and update grid smoothly. So let's jump into a quick demo to see how our suggestion works. Okay, so when the user opens the property, they're with a clean report page that brings everything inside, visuals, details, and AI insights. And so all in one place, and it will suggest similar properties for easy comparison. And each color is clickable. Just take and if you click again, it will recommend some similar strategies. And apparently this is not enough similars for this area. That's it. And also for but the most exciting part that also, so when users add a wait list, we connect both buyers and the agents, like if someone want to sell their houses, like it turns into a two-way marketplace. But the most exciting part is coming next, which is our AI assistant. It will take the property investment to a whole new level. So let's hand over to Sheldon to introduce our AI assistant. Thank you.
Okay, thank you guys. Hi, I'm Sheldon, and I'm responsible for the AI development. And today I will introduce Tina, your private smart assistant that helps first home buyer find their dream house. So what Tina can do? First, she helps with loan calculation. Tina can compare rates, deposit, and repayment plans to help you find the best and the most affordable options. Second, she offers the policy consultation. She explains government grants, stamp duty rules, and key policies you should know before buying. And third, she does property search. You just tell her your budget, preferred area, and property type, and she will show you the latest listing and price comparisons. More importantly, Tina can remember your preference. So every time you come back, she understands your needs better and tailor your needs better and tailor her suggestion just for you. Now let's see what's make Tina outstanding. First, she's fast and efficient. It has 800 lower input costs and 100% faster response than similar production. Second, she's human-like. Tina has a personality and talk like a real assistant, not just a code bot. Third, she's accurate. She's able to find the right data from over 620,000 record quickly from our database. All these features powered by our multi-agent architecture and promote caching system. So how did this possible? So first, we build a multi-agent system with one coordinator and 3 specialists. Tina is the coordinator, of course. She orchestrates the entire workflow and communicates directly with the user. Her teammates are Tom, who handles data and analysis, Ivy, who manages property and policy information, and Levin, who supports the finance and loan-related tasks. If your question is simple, Tina answers itself, but if it's complex, she asks help for her 3 teammates. During this process, only Tina maintains the user's context window. That means all response from the expert agents are refined and summarized before reaching her, which prevents the context pollutions and saving token at the same time. And also this single responsibility design allows each agent to focus on its own task and work more efficiently and independently. We also build a promote sharing system powered by Outropic's promote caching technology. It's allow agents like Tina and her teammate to reuse structured information, such as database schema or policy templates, which minimize the cost and overhead. For example, Tom is the agent responsible for managing the database, so he has full access to the entire database schema. Normally, Tina wouldn't be able to see that schema because it's too large and would take up too much context space. But with our promote caching system, Tina can access the same schema through the shared cache. This led
her understand the structure and give Tom precious, context-aware instruction. As a result, Tom can return the correct data in one go without multiple back and forth interaction, saving both time and token cost. We also designed the conversation cache system. It's automatically compressed past dialogue and keeps key detail as a persistent memory. So in the future chats, that context is automatically loaded from the cache, allow Tina to remember user and understand their preference. That's the why Tina can be called a real person assistant. Now I will give a quick introduction to the rest of the teammates. So this is Tom. Tom is responsible for database operation. He is to connect to our database and integrate with the circle generation and validated tools. And when Tina sends a query, Tom interprets it and generates circle command, validates it for accuracy and security, then executes it on the database and return the formatted result to Tina. And this is the Ivy. She is our policy expert and working with the RAG-based workflow, and she retrieved real policy documents from our vector database, re-rank them by relevance, and summarize everything to clear and reliable answers. Next, this is 11, our finance expert, and she has all loan and repayment calculation. 11 extracts key details from Tina's request, run them through our backend APIs, analyze the result, and then resolve the final answer back to Tina. So yeah, in short, with our multi-agent architecture and the caching system, we turn a slow, costly chatbot into the efficient and intelligent advisor. It can understand complex questions, remember user preference, and deliver a truly personalized experience. Yeah, thank you for listening. Next, I'm going to show the demo. Here is our windows, and you can see this button, and this is Tina. You can click this. This is the box pop up. Here's an introduction of Tina. It's your smart property assistant. It can have 3 functionality, and we can click the start chatting. And here's a quick chart. I can see the first question. All right, what can you do? Oops, I just tried again. Oh, okay, it's there, yeah. And also I gave it as what can you do? Yeah, you can see it's a return very fast, and we can maximize this to make it clear. She said this is a functionality they can provide. We ask a complex question like show me the top 5 suburbs in Melbourne West with the farthest property price growing recently. Yeah. Yeah, you can see it's asking the Tom. Yeah, it's asking for the Tom's help. Yeah, in one query, yeah, Tom can execute this one query and return the multiple result. Yeah, let's give the 5 suburb in Melbourne West. Yeah, let's give you a suggestion, and we can just follow up the question previous. And so among the suburb, which suburb have 3 bedroom, 2 bathroom, and a garage? You can see it's still calling for Tom. Ask the question. Yeah, thanks, Tina. So give us a a good answer from database. And we can also try the IV, which our the REG manager, which those property are eligible for the first home buyer for granted. Yeah, you can see the Tina is asking for the IV. Let's type yes. You can see here it says it's coding IV. Yeah, it's work. This information is retrieved from our REG database to match the result. Yeah, she said this we can't have a we don't have this apply this because of the reason. Yeah, so last question we can try for the 11. We ask the complex question like compare the loan scenario. This with one option is option B, which is the schedule is the better. You can see Athena is coding the 11. So our production is mainly focused on dealing with complex question. In this case, they can save the token saving and fast. Yeah, especially in the long conversation. Oh, it takes longer because it's it's first time asking this question. Yeah, this comes. So Tina analyzes two options, which is better. So yeah, and give the reason why we should the solution. In scenario A, what the situation is this? What in scenario B, what is happening? Yeah. And yeah, that's all. I think that's all. Yeah. And also I want to demonstrate this. It's definitely save the token. You can see the cloud console log. You can see our this screen is shows what the caching is rated. The right is the caching rated, which means the normal usage. You can see that in 80% of our data is rated by the cache, so it's very efficiently for the token and the cost. Which is very fast and saving the token. Yeah, just to prove this. Yeah, that's it. That's all. Thank you for everyone.